We are a team of two, Marco Dal Castello, team leader, and Gianluca Grappaggia, assistant. Marco Dal Castello, team leader. He designed the entire structure using the Fusion 360 software and then printed it in 3D. Moreover, he designed the PCB and soldered the components on it. He also took care of the assembly and wiring of the robot. From the software point of view, he programmed the sensors and movements of the robot in C++ and also helped to implement the mapping of the Raspberry via serial communication. Gianluca Grappaggia, assistant. He programmed the mapping algorithms using Pygame in order to simulate any maze and come back in the start cell. Moreover, he also programmed the Open MVH7 Plus cams in MicroPython to find the victims in the maze. Finally, he projected poster, TDP and video as social media manager. Dario Marchiarato, mentor. Our mentor guided us through the project with valuable advice, helping us stay focused, solve challenges, and grow with confidence. We built the robot starting from the base structure and the machine learning system for the cameras. We chose to create this robot because we were interested in the real-world purpose it is meant to serve. We designed the robot using AutoCAD Fusion 3D, with precise, millimeter-level measurements. We then used EasyEDA to create the PCB. For the hardware, we used PLA plus 3D printed parts for the base. Connected to the PCB are components such as the BNO055 Adafruit gyroscope, VL53L1X distance sensors, a PDS9960 color sensors, and microcontrollers including the ATmega 2560 Pro and Raspberry Pi 4, Open MVH7 Plus cam for the victim. Gianluca developed the camera program, using 3 high pins to identify the detected victim. He also programmed the mapping system. Marco integrated the robot's sensor inputs with the mapping via serial communication. We introduced 2 innovative features. First, we used Pygame to provide a real-time graphical visualization of the mapping. Second, we placed 2 side-facing distance sensors on each side of the robot to calculate the angle at which the robot approaches the wall. This angle is then used in a PID control system to adjust the motors and keep the robot perfectly parallel to the wall. The robot often detected multiple points for each identified victim. We faced some communication issues with the cameras, which caused us to lose some cubes. However, the robot moved well, and the mapping worked correctly. Even in the red zone, with green pieces on the floor, the cameras did not miss any detections. Despite the issues, the robot was able to overcome the stairs. It detected them as black cells because the sensors saw the dark surface too close to the ground. In the future, we would like to design a more compact and agile version of our robot. Our idea is to integrate a central joint and shock absorbers to allow the robot to adapt better to uneven terrain and overcome more complex obstacles, such as stairs or debris. Additionally, we are interested in exploring the simulation league, where we could test advanced algorithms and strategies in a virtual environment before applying them to the physical robot.